Bismillah ar-Rahman ar-Rahim. Wassalamu alaikum wa rahmatullahi wa barakatuh. Today we are going to continue chapter 12 in our book Understanding Computers Today and Tomorrow. So we are speaking in this chapter about information systems. So what is the responsibility of system development? So at your organization there will be the information system IS department. This information system IS department is responsible for an organization's computers, systems and other technology. Also called the information technology department. It is very common to use the term information technology. And who are the people who are in this information system department? We have systems analysts and we have other IT personnel. So for the system analyst, what is his role? He studies systems in order to determine what work needs to be done and how this work may be best achieved. So his role is to analyze and give you his insights, her insights, how to make things work and what is needed to be done, and what is the approach or the way that will achieve this outcome. But there are other IT personnel include business analysts, application programmers, operations personnel, and the security specialists. In the following table, we will see these different roles in your information system department. There is an application programmer who codes application software. Okay, so I think you'll ask a question, do I need in my organization to have an application programmer? You don't have to have one, but for example, some organizations, they have their own stuff, and some other organizations will get these programs done by some other companies or whatever, other organizations. So if you are an organization that can afford to have this kind of business jobs, that's fine. If you don't have the privilege to have all these kind of jobs, then you will get the service from other providers. But the information system department should be able to get the work done by putting the approach and the strategy to make things done. So what are the computer and networking jobs that might be in your information system department in your big organization? The programmers, application programmer, the business analyst, who identifies the business needs of a system and make sure systems meets these needs. Chief Information Officer (CIO) oversees routine transaction processing and information systems activities, as well as other computer-related areas, also known as the Vice President of Information Systems. So you can expect that if you are in a big organization and there is a department for the IS, there must be a Chief Information Officer in this department. A cloud architect evaluates a company's computing needs and deploys appropriate cloud solutions to meet them. For example, if you are in a hospital and you have many records for your patients and you have images for their x-rays or whatever, so where can you store all this kind of data? So it is not easy to find a place to put them in a local machine. So that's why maybe you will need to find what do you need from the cloud, and this is done by cloud architect to evaluate the needs and deploy appropriate solutions. Cloud engineer plans and conducts technical tasks associated with the implementation and the maintenance of virtualized or cloud systems. Cloud product manager, cloud service developer, communications analyst, multimedia developer, network and computer system administrator, network engineer, network operator, troubleshooter, network systems and data communications analyst, network technician, security specialist, software engineer. So we have many jobs, and we have other more jobs: computer operation manager, database administrator, database analyst, data center architect, data entry operator, help desk technician, information engineer, knowledge engineer, web programmer, web designer, web developer, webmaster, trainer, systems engineer, systems analyst, system programmer, system administrator. So these are the kind of computer and networking jobs that if you have a very large big organization, I expect that you have these roles filled. But if you have a small business or small organization, you can have some of them in your organization and some from outside. So this means that you might need some term called outsourcing, hiring outside vendors to perform specific business tasks, because if not every organization can have this huge large information department in information systems department in their organizations. So if you ask outside vendors to perform this business task, we call this term as outsourcing. So the outsourcing will be, we have three options. Offshore, if you are outsourcing this job to another country, something outside your country, and near shoring if it is a nearby country, and home sourcing or home shoring if the outsourcing to home-based workers, to a company or workers inside your country. There is another job called crowdsourcing. Taking job traditionally performed by an employee and outsourcing it to a large undefined group of people, often performed via the web. So I'm not very sure if you heard about this term before. Crowdsourcing is used for the data annotation in many applications. So for example, some companies like those who are doing self-driving cars, they allow you to access their database if you are going to annotate some images for them. What does it mean to annotate images? To mark the people in an image, to mark the streets in an image, to mark the crosswalk in an image, to mark cars, pedestrians, and traffic signs, and so on. And this is usually is done. This job is done by many people, not just one person. It is offered on the web, and the one who find himself or herself qualified will do this crowdsourcing task and get some reward for it, from it. Advantages for this crowdsourcing: it is lower cost, and it is also and outsourcing as well, and flexible staffing. So you don't have to have your staff full capacity all the time if you have this job is doing occasionally, not at very often rates. So it allows also this global sourcing, strategic sourcing, and socially responsible outsourcing. What are these advantages? Personal changes at the outsourcing company. If you are doing outsourcing and then something happened in the outsourcing company, so the personnel that you need to contact with is changed or laid off or whatever, so this will make your life harder. Conflicts between in-house and outsourcing personnel, whose decision is going to rule here. So if you see from your organization that this job has to be done that way, and some outsourcing personnel says that no, it has to be done this way, so they might raise some conflicts and so on, because they are not in the same procedure. Not in the same organization, and they're not following the same rules, and that's why communication problems and the cultural differences might make some disadvantage here. The quality control and security. So if you are outsourcing your job, then you are sacrificing your security for your data. So because now it is accessed by some other company or some other organization. Captive offshoring. Some US companies own facilities in other countries and they hire employees in that country. It gives the company more control over employees and the procedures than the conventional outsourcing, because now they are following the same company strategies. So this is captive offshoring. Okay, I think it's time for a quick quiz. Which term refers to outsourcing work to another country? Yes, sure, it is offshoring. Another country, so it is offshoring. Is it true or false? The IT worker who codes computer programs is called a computer operator? No, it is application programmer, right? So it is false. The IT employee most involved with system development is systems analyst. So this table is very important. slide 42 and slide 43, because it distinguishes between the different computer and networking jobs that might be in your information system department. So yeah, now we are going to the most important part of this lecture, the system development life cycle, SDLC. SDLC. It is the life cycle for the system to be running. It starts with step number 1, which is preliminary investigations, and it goes for system analysis, analysts, and then system designs and system acquisition, system implementation, system maintenance. And while you are doing this maintenance at every step here, you find that you are writing documentation. The documentation at each step might produce different kind of documentation, but at every step you have to document what you have done in this step. And while you are maintaining your system, you might need to update or upgrade your system. So again, you are going in a cycle now to investigate what changes need to be done, and so on. So the system development life cycle, SDLC, is the development of a system from the time it is first studied until the time it is updated or replaced, and that's why it takes these 6 phases in a cycle. Okay, let us start with the first step in this cycle, which is a preliminary investigation. If you are going to do system develop your system or you need a system to be developed in your organization, the very basic step is to do this preliminary investigation. The preliminary investigation includes a feasibility study is performed to assess whether or not a full-scale project should be undertaken. The feasibility study will produce feasibility report. So at every step, like I mentioned, you will find a documentation for this step. So you write a feasibility report, contains finding on status of existing system and the benefits of feasibility of changing to a new system. It includes system analyst recommendations regarding whether or not the project should move on to the next stage of the SDLC. So at this preliminary investigation, you have the right to stop or to continue according to the system analyst recommendation. So, but this is the most important step to that you need at your organization to have it done. The next step is to do this system analysis. The system analysis examines the problem area to determine what should be done. It includes data collection, gathering information about the system, organizational charts, observations, interviewing users. So this is kind of data collection, and then the data analysis, which takes many steps. Analyzing information to determine the effectiveness and efficiency of current system and or requirements of a new or modified system. So you analyze this information to determine effectiveness and efficiency. While you are doing this data analysis, you develop this entity relationship diagrams, ERDs, and data flow diagrams, DFDs, used to model the entities in the system and the flow of data within the system, provides a visual representation of the data movement in an organization. You also, in this system data analysis step, you are going to write decision tables and decision trees, and this is very useful for identifying procedures and summarizing the decision-making process of one step of a system. This figure shows us some examples of what is meant by data flow diagrams and what is meant by decision tables. So in these conditions, you take these actions. So if you have a new customer, possible order scenarios, and new customer, yes, no, whatever these cases, and then if this happened, then you will take this action, and so on. And also the data flow diagram process payment, it relates the entities and the data, how the flow is going from one entity to another entity. And also in the system analysis step, you are going to make this business process modeling notation, PMN, which is a graphical standardized notation used to model business processes. It is used to model the business processes and used within the systems, and it is designed to be understood by all individuals involved in the system and that's why it is likely to be graphical, to be understood by everyone. It expresses the processes graphically using diagrams similar to a flowchart. So for example, there is no example here in this part. Also, you have class diagrams and use case diagrams, and they are used to illustrate systems that are based on the concept of objects. For example, this class diagram, if you have a class called the customer, so what defines a customer? It's defined by its attributes: name, address, telephone number, email address, password, credit limit, balance, and so on. And you have some functions that need to be implemented for the customer. For example, if you'd like to change your phone, change address, change email, change password, make payment, place order. So this is called a class, and the class has attributes which defines an object, and functions which operates on an object. And also we have these use case diagrams. You have the customer who might be able to update information or make payment or place order. So this summarizes the functions that is written here in three ovals: place order, update information, make payment. And these three ovals will contain some functions from what we have defined for this customer. At every step you have to do this documentation using diagrams, tables, trees, and models. Consists of any instruments used for data gathering and the resulting diagrams, trees, models, and other tools used to summarize and analyze the data. It takes forms of questionnaires, interview questions, diagrams, and models, etc. The next step after this system analysis, so again let's return to this system development life cycle: preliminary investigation, system analysis, and now we are in the system design. So in the system design, it specifies what the new system will look like and how it will work. Developing the design and the specification of the new system, models of the new system is developed. So you are doing the modeling here, and the diagrams can include data dictionary, which describes all data in a system, data flow and or class diagrams of the new system, user interface designs, and so on. So for example, this is a user interface design for an application. It can be sketched on paper or using your notepad or whatever. You can generate such wireframes and this system design for your user interface. You are also in this system design, you are doing this cost benefit analysis, considers both tangible and intangible benefits to determine if the benefits of the new system outweigh the cost. And also, again, don't forget, we have a documentation step at every part in this cycle. You document the system design and the specification, and this is developed using during the system design phase, and it consists of all documentation necessary to illustrate the new system. The fourth step in this cycle, the system development life cycle, is the system acquisition. The system analysts determine where to obtain the necessary hardware, software, and other system components. So I will get the hardware from company X, I will get the software from company Y. Maybe I can develop things in-house. So there is a very important decision to be taken, the make or buy decision. So determining if the software needed to be purchased will be purchased from a vendor or developed in-house. If developed in-house, software to be developed moves into the program development process, which is another cycle that is in chapter 13. Make or buy decision. In this decision, you might need to release something called RFPs, which is a request for proposal, or you contact companies and request for quotation. The RFP is a request for proposal. It contains the list of technical specification for equipment, software, and services needed, and the request for quotation names the desired items needed and ask for a quote. At your department, you have to be able to evaluate the bids coming from outside. So you have these procedures for evaluating bids and something called benchmark test. Again, don't forget the documentation in this system acquisition step. Documentation in the form of RFPs, RFQs, and vendor evaluation material. It includes the RFP or RFQ sent to potential vendor, proposals received, the documentation produced during the evaluation of the bids. All of these are parts of the documentation in the system acquisition step. The next step is the system implementation. So we have now the system. The new system might be a new original system, or it is updating the system that is developed already at your organization. So once you have your system installed, tested, and made operational, you need to complete things by data migration. And the system must be thoroughly tested. Test data should be realistic and include incorrect data to see these failure cases if happens. So if you are going to convert your system from V1 version 1 to version 2, so what can be done? There's several ways to do the conversion. Once the testing phase is completed, system is installed, you can do this direct conversion. I will deactivate the old system and activate the new system immediately implemented. Or parallel conversion. Both systems are operated simultaneously until it is determined that the new system works properly. So you might let the two systems work on the same time. Phased conversion. The system is implemented by module. Pilot conversion. The new system used just one location within the organization, and if it is successful, then it will be generalized. And also in this system implementation, you have to have user training. All training manuals should be developed and given to users. Training takes place on the actual system. Can occur one-on-one or in groups. You can train the users collectively in groups or one by one. And also at every step, don't forget the documentation, the implementation schedule, the test data and results, the training materials, and so on. The implementation schedule, test data, test results, training material should be saved for future reference. This figure shows you some types of conversion. You have the old system, stop it at this point and implement the new system. And this is called direct conversion. You have your old system, the new system is ready here, so you make them work in parallel. At the same time they are working, so this is a parallel conversion. And at the end, once you are satisfied with the new system, you will close the old system. We have also this phased conversion. You have module number 1 implemented, so the new system is working but for few modules, and then module 2 implemented, then the new system is working with 2 modules, and at the end it works with all modules, so there is no need for the old system at the last module, and we call it phased conversion. Pilot conversion, you implement the old system but in all places, but in one site only you implement the new system, and once you are satisfied with this, you will implement the new system at all other sites. The last step in the system development life cycle, it is a cycle, so it is not the last step. It will move you again to the first step, but it is the system maintenance step. It is an ongoing process. Minor adjustments are made to the finished system to keep it operational until the end of the system's life, or until the time that the system needs to be redesigned. So that's why it takes you from this step to the preliminary investigation again. It can the system maintenance also will, at the implementation, you have this system delivered and working, but you have to review it after the implementation step is done. Identifies any glitches in the new systems that need to be fixed, and also sometimes there might be some major change that is needed. The project goes through the SDLC again. Don't forget again the documentation step. Completed project folder, result of the post re-implementation review, add to the accumulated documentation. Information can be useful to auditors from the company or from outside, who may check that to see the proper procedures were followed. So in summary, so this is a traditional approach for the system development. It follows this SDLC cycle, the system development life cycle. They are carried in the preset order: preliminary investigation, system analysis, system design, system acquisition, system implementation, maintenance, and again doing this cycle. But there is some other approaches to the system development. So the first traditional approach is DLC, and we call it also the waterfall. Each phase begins only when previous one is completed, but it is time consuming because you have to go to the second step. When you finish the first step, you cannot go to the third before finishing the first and second. So there's some other approach that allows you to go with your system earlier, but it might need more revisions, which is called the iterative approach. Iterative approach is a system is developed incrementally, step by step. You are doing for example, the exports at one point of time, then you are doing for the imports, and so you are doing everything for the exports first, and then everything for the. So at this step, you can sell your, or you can have your system working on some module and some other modules not yet. You can do this using something called the prototyping. It is a small model or prototype of the system is built before the full-scale development effort is undertaken, because it is time consuming. So we have these two things. The first one on the left with the waterfall starts with preliminary investigation, system analysis, system design, system acquisition, system implementation, system maintenance. And with the other iterative approach, it is called the prototyping. Investigate and analyze the situation, design and develop prototype, which is a small model, implement and test the prototype, gather and evaluate your feedback, acquire additional hardware, software, and implementation to maintain the final system. So the final system is not implemented at the beginning. You are just implementing a very small model of it and make sure everything is going right with you. Then you at the end you will go for the full implementation. The end user development approach, user is primarily responsible for the development of the system. Most feasible when system being developed is small and inexpensive. Measures must be taken to ensure that the system is compatible with existing systems and no new problems are introduced. So it's time for the last quiz in this lecture. The first step in the system development life cycle is to design, to perform preliminary investigation, or to implement. The first step is the preliminary investigation, as we just mentioned in this lecture. True or false, the traditional approach to system development also is referred to as waterfall. Yes, this is true. A test used to evaluate or measure a system's performance is called a benchmark test. Okay. So today we covered what was remaining from the information system lecture, and we have seen many important things. What is an information system and what are the types of information systems? And today we covered responsibility for system development and several types of jobs in the IS department, and the system development life cycle is DLC. Very important. It is six steps, and you have to do the documentation at every step. And we have seen the approaches to system development. We have three approaches: the waterfall method, the prototyping method, and the end user method. Thank you, and see you in the next lecture, inshallah.